Hello, everybody, and welcome to our tech talk today on essentially looking at various cloud native languages to treat infrastructure as code. My name is Kevin, and I will be acting as your host and your presenter for today. Quick way of introductions. And my name is Kevin Ung. I am a senior solutions architect in the pre-sales team. And I've been working in the DevOps space and container space for the last decade or so, working with Fortune 500 companies to essentially help them with their development and deployment process, working in everything in continuous delivery, testing, provisioning, and improvement, essentially everything continuous as in true DevOps fashion. A few things we're going to be looking at today. And I think you're all here because you want to know, what is the best cloud native language for, infrastructure as code, right? In your deployment process and so on. So what we'll do today is we'll go through a quick overview of the various tools. We'll look at an actual process. We're not going to do a deployment because there's multiple tools. If I do a deployment, this will be a very long webinar. But what I'll do is I'll kind of walk through the processes of doing the exact same scenario using these various tools and how they compare and contrast. And we'll look at a kind of comparison at the end of the strengths and weaknesses and ideal scenarios for each tool. So before we start looking at the tools, and I guess the first thing we should do is really level set on what we are looking at, what we're trying to achieve here. And we're looking at infrastructure deployment automation, right? As opposed to workload deployment automation, which is kind of a separate thing. And when folks think about deployment automation, there's actually two different layers to it. There's one where is the actual infrastructure management side of things. So these are things like provisioning, monitoring, maintenance of your actual hardware, your networking components, let's say, for example, and perhaps other things that are needed in there, right? So these are creating and configuring your storage, your servers, networks, and adjusting them so that it fits your workloads. And then the layer on top of that, which is your configuration management, that focuses on kind of controlling the state of your software and components in a reliable manner, right? So things like once you have your compute up, what resources do we need on top of that? Do we need to install a database to make sure that database is set up and connected to your workload? Or Kubernetes, is that set up and make sure you have the right kubeconfig files so that you can actually connect to it from your machines? And so let's look at this from a more practical stand. In your typical container DevOps pipeline or DevSecOps pipeline, we go through a number of different operations, right? And this is on the workload side of things. And this is what folks usually focus on when we talk about release automation or deployment automation. But then what we're going to talk about then is on this side over here, in order to deploy your workloads, of course, we're going to need to make sure we have our infrastructure to run on. Right? The first thing we need is our compute resources in the sense of containerization. We need to make sure we have container runtime on top of that. And in terms of Kubernetes, we need to make sure that our Kubernetes cluster is connected up in that infrastructure as well, so that there's something to deploy to. And then if we tie that back to our two deployment automation layers, we've got the infrastructure automation or infrastructure management that deploys the actual compute, and then the configuration that then does the runtime, the orchestration, logging, monitoring, alerting, which then provides us with an environment that's ready for workloads to deploy to. So let's get right into the meat of this. The tools that we're going to be talking about today, and this is in no way, shape, or form an order of anything. It's just a random order that I went through the tools in. So we'll be talking about Pulumi, Terraform, Ansible, Chef, Puppet, SaltStack, and Vagrant. And the quick thing to note as well is we'll be talking more about the open source version because each of these, well, just about all of these, also has an enterprise offering, which provides more enterprise hardening, security, et cetera, on top of that. So we'll look at just purely the open source versions of these for now. So let's start off with Pulumi, with each of these tools. So Pulumi's been around, 2018. It's actually launched in 2017, I believe. So looking for a modern infrastructure as code tool, the idea is it gives you kind of a general purpose interface, I should say, right, to the tool. So as in contrast to some of the other tools, Pulumi allows you to actually define your specifications using different programming languages like TypeScript, JavaScript, Python, Go, .NET, and so on and so forth. I'm also sharing with you some of the metrics I was able to gather on the GitHub repos so that you could decide, how popular is this? How much is it being used? How is it maintained? And so on and so forth. So you can see over here, Pulumi's got about 20,000 GitHub stars. It's actually dependent by 7.2 different thousand different projects as well. But the contributor count, want to look at that as well. We got about 271 contributors on that. So not bad. It's starting to gain pretty good traction. Yeah, most of these tools, and not all of them, do support multiple cloud providers as well, if not very least the major public cloud providers, right? Your AWS, Azure, GCP, and so on. So those are kind of the things behind this. Terraform from HashiCorp is actually also the company that gave us Vagrant. We'll see that a bit later as well. The background, there's not a lot of metrics over there that I can find apart from stars and contributors. I can't actually see how many times it's been used as dependent sources from other side of things, right? Or download numbers are a bit hard to come across as well. But we all know Terraform. Most of us, when we talk about infrastructure as code, we talk about Terraform. And the language there, we do have to look at their HashiCorp configuration language, or HCL, and bit of JSON as well when we're doing this. So it's a new language to learn. The good thing is it's not that hard to go through. It does have a pretty significant number of contributors, got 1,800 those, and about 41,000 stars. And then when you look at the next one, that's actually the numbers get really interesting, where we go into Ansible, founded in 2012. So it has been acquired by Red Hat. One thing I did forget to note as well is, see over here, I've also included the domain organization that it belongs to. So Pulumi is Pulumi, Terraform is HashiCorp, and Ansible has been acquired by Red Hat in 2015, and I believe it's starting to be integrated into their enterprise solutions as well. So Ansible, again, like Terraform, is one of those things that folks typically think about when we talk about infrastructure as code or deployment automation type languages, primarily through YAML. So it's quickly becoming the default language of the cloud. So those of us that work in Kubernetes, we're not getting away from YAML, unfortunately. So getting into Ansible will be pretty familiar. It's a similar language. It does have a pretty significant contributor count. If you look at this, over 5,000. I can't even get a proper number from GitHub. It just says more than that. And it's dependent by quite a number of different projects as well. So you can see it's pretty robust. It's pretty widely used and doesn't sound like it's going to go anywhere soon. For some of us that's been in the release automation world, kind of before Kubernetes and stuff, we'll probably be familiar with the next two names, right? Chef was released in 2009. It's been acquired by Progress Software. It used to be Chef as well. So we looked at this as its configuration management and continuous deployment tool. We used to put that into our release automation pipelines as well. The language it's using is Ruby based. So it's another domain specific language that, if we're not familiar with Ruby, that's something that we'll have to pick up. Again, because it's been around for a while, there is quite a bit of documentation, and a lot of folks use Chef in the enterprise world as well. So there's plenty of resources to kind of read from, right, and learn from. About 7,000 stars. I think it's open sourced in 2010 there and thereabouts. So it's been around for a little bit as well, and about 600 odd contributors. So I think right now after being acquired by Progress, it's being put into their DevOps suite as well. So if you look at the enterprise side of things, it's kind of in there. Another one of the tools that are familiar by some of our old school folks is Puppet. So Puppet and Chef is, I think, the two back in the day. 2005, it does have its own domain specific language. And it's more about configuration management and automation, right? Again, we'll kind of look in more detail at the two, right? So remember, we have the two sides. We have the infrastructure, automation, and the configuration. So this is kind of what we're looking at here. Acquired by Perforce, and same deal, about 7,000 stars and 500 odd contributors. So you see the contributor count is a bit more focused on this sense between Chef and Puppet. Last two, got SaltStack. SaltStack 2011 is pretty fast, pretty scalable. It's good for configuration management and orchestration. It does use YAML and Jinja templates, and I believe it uses a bit of Python in the backend as well, right? 14.2 thousand stars and 2,000 odd contributors. It has been acquired by VMware being put into its realized suite and in turn being acquired by Broadcom. So it's now part of Broadcom VMware. Take that as you will. That's where SaltStack has now ended up. So it's going to be put into the vSphere visual VMware kind of suite of things. And then last is Vagrant, last but not least. It's actually earlier than Terraform. It's actually the main reason why HashiCorp was created in the first place. So Vagrant started up in there, and then HashiCorp came around to support that. It's really there to create, still until to this day, deployment environments. So it does give you a really easy way to reproduce and recreate your deployment environments. You can actually spread it around through your development team. But as of today, I think the general consensus is still more geared towards dev environments. And when you're looking at prod, there are additional things you will need to look at to harden it a bit more. 26,000 stars, quite a bit of dependencies, and it's good. I like this number. It's 1024 contributors. It's a nice binary number, right? So that's kind of a bit of a background to the different tools and the repos. And again, this slide will be shared, of course, on our Tech Talks website, so you can have access to go through and look at all of those repos. And these are perhaps things that you've already looked at already, right? So not any new news. So let's look at something a bit more practical and look at an actual scenario using all of these different tools. What we're going to look at is we're going to install K0s, which is our Mirantis open source Kubernetes lightweight Kubernetes distro, and we'll deploy it on an AWS EC2 instance, or 3 EC2 instances to be exact. So what we're looking at here is really a comparison of what will the different tools look like when we're trying to apply the exact same steps using these tools. So the installation steps will be relatively straightforward. We'll create a VPC so that we can talk to each other. We'll create the security group so that we have all the access controls and everything set up. We'll launch 3 compute instances, 3 EC2 instances, and then we'll install K0s on top of that, and then make sure that the end user has access to the Kubernetes cluster, which means gaining access to the kube config file, essentially, at the end of the day. So before installing, prerequisites will be slightly different for all of the different tools. So when you look at the various tools, of course, you're going to need your AWS account. That's a given. But interfacing with the AWS instance is slightly different for these tools. So when you look at Pulumi, you have your Pulumi CLI you're installing. And then on top of that, you have to additionally install your AWS CLI, which you'll interact with. With Terraform, you install Terraform, and then it's got built-in modules to interact with AWS instances. When you look at Ansible, kind of the same thing. You have Ansible, and then you install Boto 3 or Boto Core to provide the Python AWS connection. So it's Ansible, as we know, is kind of Python based, right? So you need to install that additional thing within your Python environment so that you have that interaction with AWS. With Chef, you have Chef is more of a server agent and server workstation architecture. So we'll install Chef Workstation. You'll have your Chef server going on, AWS CLI to interact with it. You also have Knife AWS that interacts with the actual compute resources. So we'll have to make sure that these are installed. Similar with Puppet. Puppet, you have the core Puppet components, AWS CLI, and then the AWS modules are additional things that you have to include into your Puppet environment. With SaltStack, quite similar to Ansible, with the addition of an additional AWS CLI you have to install. Does use Boto Core as well to interact with the AWS compute. And Vagrant, again, pretty similar, AWS CLI, and also the Vagrant AWS components. So as you can see, it's minimal. Looking at the various tools, though, you see that essentially Terraform is the one that does just about everything out of the box. The other one, although you have some minimal installation requirements, it's still additional. Having said that, though, I think if you're working with AWS, you probably already have the AWS CLI installed on your machine, so it's not going to be a very much of a heavy lift. But these are things to look out for when you're putting that into your machines, especially if your machines are, controlled tightly by policies and so on and so forth. The steps for installation vary slightly. Most of them, though, essentially require you to have a core script, Pulumi, Terraform, Ansible, Chef, Puppet, all of them, a series of core scripts that define two things, right? One, your infrastructure, so the EC2 instances, and two, the actual installation. How they're broken up are slightly varied between the different tools. So as you can see over here, for example, Pulumi. We've got the main.py that defines everything related to our AWS EC2 specifications. But then we also need to create a separate install script and then manually install K0s on top of that. So the configuration side of things is a little bit more hands-on or manual in the sense of Pulumi. When you look at Terraform, we do have, we have everything kind of defined within our Terraform script, and you can actually include the install script into that Terraform script as well. And then we just essentially run it, but you still have to go into machines and essentially hook up K0s, right? It's there, but then we have to make sure it's hooked up. With Ansible, we create the inventory. We have the playbook that installs the actual infrastructure, and then the K0s playbook to actually install K0s. You execute it, and everything's hooked up. So it's actually much more powerful when we're looking at the configuration side. And we'll go through each of the scripts later on as well, so you can actually see what's going on there. Chef, similar thing. We set up the gem, so you have to include it first. Two different Ruby scripts. And then the interesting thing is you then have to go through and bootstrap each of the nodes separately. You could probably script it, but it's still a manual process to a certain extent. Puppet, same deal, a bit easier. You have the setup for the networking instances, K0s, and then do apply, and that's it. SaltStack is similar to Ansible. And then Vagrant, you do have to manually set up the groups within AWS before you actually go through the setup process. So there is a bit of a dependency. So you see a number of manual steps that are needed for some of these tools. So let's look at some of the main scripts in each of the tools to see, how familiar are those to what you're currently using, right? So you see over here, Pulumi, I created this one using Python. And as you know, you do have the availability of using other languages like .NET or TypeScript or JavaScript in order to do this. It really depends on your familiarity with these programming languages and what your internal standards are in terms of creating different classes and processes. Right. So over here, you see we define things like creating a new VPC, the security group, launching the EC2 instances. And then on top of that, after we're done with this, we also have to create a separate script for K0s and then actually run through that. To a certain extent, I mean, you could program it into Python if you wanted to and then run those. It's just going to be a separate thing altogether, right? So after you're done that, you then create your install script and then install the K0s components using that script on each of the machines. With Terraform, it's a bit more comprehensive. This is the structure of the Terraform HCL. So it's essentially defining a resource and then the different parameters of that resource. So actually quite similar to if we look at it using YAML, it's just a different structure. It's kind of JSON-like if you look at it, right? So if you're familiar with these type of languages, it's probably just or data structures, it's just a slight adjustment in order to get into this. And then as you can see over here, you could also add in some remote exec steps as well. So over here, we're just adding in the steps to deploy K0s and then get to our kubeconfig, right? So the additional thing on top of that then is just going in to make sure that your K0s is all working properly and hooked up. So this is all one script within Terraform. Now, Ansible, you see we call this an Ansible playbook. So the Ansible playbook is slightly different to the Terraform definition, where one's more of a declarative and one is more of a imperative type standard, right? And we'll look at the comparisons later on as well when I look at the different tools. But you see over here the step-by-step instructions for creating the AWS infrastructure, creating all the security groups. So one instruction after another. And then once that's done, we execute a second playbook installing K0s that goes through and actually does each step-by-step process within shell. And those of us that are familiar with YAML, this is a pretty familiar sight. Okay, within Chef, Chef uses cookbooks, like the name Chef states. So you have the create infrastructure cookbook. This is the Chef, the Ruby syntax. We set up the K0s as well. So the steps that needed to go through this is we go ahead and create the cookbooks. We upload the cookbooks onto the Chef server. We then bootstrap the nodes by running these commands. So we do a knife bootstrap on each of the nodes, and then that go through and run through all the recipes on each of the nodes there, one by one. And then you go ahead and go into the nodes and take the kubeconfig files and then copy them over via SCP or whatnot. And then you can then access it using kubectl. So slight difference in terms of the order of operations. That's what Chef would do. Okay, we look at Puppet, very similar. We then have a Puppet, their own domain-specific language, right? If you look at this, it's actually quite similar to a Terraform HCL, where you have your instance type and then the different parameters in it. The syntax is slightly different, and you also need some additional parameters like ensure and so on and so forth, right? Make sure it's present or whatnot. So these are additional things that are needed. And then within the actual K0 setup, we could actually go through, make sure your curl is installed, and then run through some number of curl commands in there, which of course means you need to have access control and everything set up as well. And SaltStack is again pretty similar. You see over here the syntax is basically just YAML. So most of the scenarios that you run into in SaltStack, you probably do using YAML. There is some additional requirements for Python if you want to do something a bit more customized or a bit more involved. So those are things to look out for as well, right? Do you want to learn Python? And I think just about everybody in the world has learned already. So I think that's probably not much of a concern. And again, as you see, you have your infrastructure and then your setup in here. And you see this is more of a declarative type statement. There's no real order of steps. It's just making sure that we have these sort of things. Whereas in this one, it's kind of more sequential. And then Vagrant. Vagrant is over here is a bit more interesting in terms of its language. Most of these, again, programmers will probably look at this and we'll be able to hash this out relatively quickly. The thing with Vagrant is that you do need to make sure that other things are already there. For example, you do need to make sure that your SSH keys are already provisioned in your AWS account. You already have a security group created in your AWS account as well. So the subnets and security groups, these are all already pre-configured before you run the Vagrant files. You also need to make sure that all the right ports are opened up, your SSH ports, Kubernetes ports, and all of that, and your subnet IDs. So that means there's quite a bit of manual setup before you do your setup here in Vagrant, and then you'll run through your Vagrant file, and then again copy your kubeconfig over so you can access it using your machines. So that's kind of an overview of the scripting that you're going to see in each of the tools. So some observations when you're looking at the tools here. All right. Let's look at the thing that is probably going to be central mind for folks. How easy is it to use? So with Pulumi, the benefits, of course, is that it allows you to write your infrastructure as code using general computer programming languages that we're already familiar with, like TypeScript, Python, Go, C++, C#, and so on and so forth. So it's good if your operations folks, your DevOps, your environment folks are already familiar with these languages. If not, then of course it's a new thing to learn. And one of the things as well is because of the flexibility, it also comes with more need for regulation standards. Maybe not regulations, but more need for standards because one can program a C# or a Python class in one way and using object-oriented standards, create your different classes, dependencies in one structure, and versus the next programmer who could do it slightly differently. So I think with this, it's going to be important to make sure that if you're going to use Pulumi and you're going to use any language in your definition, that perhaps uh, align that with your development team as well in terms of development standards and architecture and how you create your classes um, and um, and projects. So that'll make it a bit more standardized. Otherwise, you'll have two different structures, and it's really hard for other people to come in and pick that up really quickly. With Terraform, it does use a different declarative language. It's HCL, but again, it's pretty well documented, and I found it to be relatively intuitive. Right? If you look at that, it's just a definition of your resources and the different parameters needed for that resources. So it's relatively straightforward. Ansible uses YAML, so if you're anywhere near a cloud environment, you already know YAML, so it's pretty easily readable in the syntax form. And even with minimal coding experience, it's pretty straightforward. Chef uses Ruby, which means we got to learn Ruby. And there are plenty of Ruby programmers out there, and it's still a pretty popular language, right? So there's plenty of resources there. The complexity, I guess, is there is a bit of a learning curve involved in that because you have to come and learn Ruby and then look at how the Ruby structures work and managing your recipes and cookbooks makes it slightly harder to learn compared to some of the other tools here, right? Puppet does have its own declarative language. The syntax could potentially be complex. And we use the word potentially because that really depends on your environment as well. And we'll look at, if you have a more complex environment, meaning it's more dynamic, you have dependencies, you have a lot of conditionals, then one will probably be better than the others, right? So those are things to look out for. SaltStack uses YAML. For more complex stuff, uses Python. So again, like Ansible, it's pretty easy to pick up. But then when you start going to the more complex Python stuff, you have to learn Python. Vagrant really focuses more on the automation and creation of development environments, right? So Vagrant Files has its own specific configuration language. So you do have to learn it a little bit. It looks a little bit similar to kind of the older, it's kind of Python, Haskell-ish type languages. So, I mean, depending on you're familiar with programming languages, it's probably not that hard. But it does provide some complexities to new folks that are not familiar with programming. So again, things to keep in mind here. Now, one thing we didn't really talk about as much in the previous side of things is security, right? Of course, that's should be top of mind when you're looking at this. Now, when you look at the open source version of each of these, now all of these do have enterprise hardening on top of what you already have, right? So when you look at security, Pulumi has secrets management within the open source version. It also integration with things like Vault and Secrets Manager and Key Vault and so on and so forth. So you actually do have access to your own secret management system if you want to. There are some basic access controls and RBAC, but then the more advanced features, of course, is in the enterprise version. Compliance, that's the other side, right? So one, we have the access controls, then we have the compliance, making sure that your scripts are compliant in terms of security. You're not exposing things by default. It does have some compliance management capabilities. One thing to note about Pulumi, though, is I don't know if that's still true now, is that it's primarily still a SaaS first application. So I've heard of stories where by default, some of the information is still being sent over to the SaaS instance of Pulumi. It could have been taken out by now. Again, don't quote me on this. So these are things you might want to dig into a little bit more if you're looking at Pulumi to make sure that it's not calling back home. It can be turned off easily. You just need to know to turn it off, right? If you want to make sure things are kind of contained within your environment. Terraform, in terms of open source, it has state file encryption. So it does allow you to encrypt the files, whether it's locally or remote backends. So that's a good thing too, so that you're not exposing your configuration into the wild. Also has secret management integration, as secrets manager, your key vault, HashiCorp vault, and so on. There are as well some basic RBAC controls, RBAC access. Again, more advanced features, team access and so on. That's in the enterprise version. And it does have some basic compliance checks. You need to go into the enterprise version for more advanced checks, or look at an alternate solution for compliance checks. Ansible, it's got Ansible Vault to encrypt your secrets, sensitive data, and does have compliance management in the form of open source modules that you bring it in, right? So if you want to do something more complex, you have to do more complex development or custom development. One thing you do want to note as well is the agent feature as well. So Ansible is agentless, as with some of the other tools as well they're actually agentless in nature, which means it's one less attack surface, so to speak. But on the flip side, it also means that the connection, you do have to set up the security in between those. So that's one thing to look out for. Let's see, Chef. It does have encrypted data called data bags that allows you to encrypt your security, your sensitive data, your secrets. Also has secret management, compliance automation. It does have a tool called Chef Inspect that actually does compliance check automation. So it does require some setup and maintenance though. So those are things you want to look at if you are going to be using Chef, the open source version. It is available. For Puppet, you have encrypted communications, as with all of them. In terms of secret management, I haven't found much in that aspects. It does have basic role-based access control. And then there is compliance checks, but it's only available mainly in the enterprise version. So, and I think there's basic compliance checks being done using Puppet's own language, but it's very rudimentary. Salt and Vagrant. So SaltStack has encrypted communication as usual. RBAC is available. Secrets management, you have to integrate with others, Vault, etc. There is no real compliance automation in the open source version. It's primarily supported through the enterprise version that I found. In terms of Vagrant, encrypted boxes, it doesn't really have much in terms of everything else. In terms of compliance features, a role-based access control, because it's more geared towards individual developer use. So there's no roles, so to speak. It's only one person. So hence the suitability for development versus as opposed to production environments. We kind of grouped them as a whole. Let's look at these in terms of suitable scenarios, right? So we looked at the scripts that you need. We looked at the ease of use of picking it up. We looked at the security functionality, and then setting up is relatively straightforward. You go through and you perform, typical installations like either doing brew or pip and so on and so forth. So they're all package managed. So installation is relatively straightforward. Let's link it back to our two different use cases when we're talking about infrastructure provisioning, which is one, the infrastructure management, and then two, the configuration management. And this is my personal grouping of the tools. They could, of course, as you can see in the previous deployment scenario, they can actually span the two different domains. But there is one where they're stronger in, and then one where it's available, but weaker in. So I'll group Pulumi, Terraform, and Vagrant in more of the infrastructure management side of things, which is the deployment of the actual compute, setting up the resources, making sure that your environment is ready for you to then come in and configure and deploy your workloads onto. And so that comes into the configuration management side of things. So Ansible, Chef, Puppet, and SaltStack will be more geared towards the configuration management. You have your infrastructure ready, and then you configure it using one of the tools. And this is a common pattern that we see for a number of folks as well. We see, even in our internal use, a combination of one tool from the infrastructure management group and then one from the configuration management group. And of course, if you, on the interwebs, you see the most popular combination is Terraform plus Ansible, right? You use Terraform to deploy your infrastructure, and then Ansible to deploy the configuration management. That's what we use internally as well for a lot of our projects. But of course, there are other things other combinations that you can actually use, right? Terraform is Chef, Terraform Puppet, especially if your organization already has an existing investment in Chef or Puppet from before as well, right? It's best to utilize that existing relationship and perhaps complement it with a infrastructure management tool to then, have a more robust infrastructure deployment process. That's how I would group it within the two different groups. And I would recommend having one of each group to actually complement the entire process. And then within each group, how would you then make the choice of which one to use? So if we look at the three, Pulumi is good for infrastructure provisioning, and it's probably pretty good for complex infrastructure provisioning. Reason being, you're able to use our quote unquote general use traditional programming languages to deploy your infrastructure, which means you get the benefit of all of the different structures that you get from those programming languages as well. Your conditionals, your looping, and additional nested processing as well in those programming languages. So you could actually come up with more complex rules and deployment patterns for your infrastructure. Again, be careful not to fall in the trap of overcomplicating things as well, right? So someone writes a very elegant and complex if-else loop, and then have some other person coming in and try to decode it is going to be an issue. Terraform, pretty good for large scale deployments. It's pretty widely used. HCO is relatively straightforward to look at, and it's geared towards heavy uses and large scale, larger clusters, larger environments. Vagrant, again, you'll probably use it in conjunction with Terraform as well. It's very good for development environments. It gives us repeatability throughout all of the different environments. So, if you want to give your dev teams an environment to use, that would probably be a good thing to look at as well. Now, in the sense of Kubernetes, there's a bit of a caveat. So I'll talk about that when I go through all of the different tools over here. So that's kind of the classification when we look at our our infrastructure management tools, right? So weaknesses, you want to look at these. And then I've also put in some of the paradigms over here in terms of the tools. So you see Pulumi and Vagrant is more imperative. So it's a sequential step-by-step process, whereas Terraform is more declarative. So make sure that your state matches this versus I have to go through all the steps of runbooks to install them. The reason why that's important as well is for Terraform, you're able to apply your Terraform script multiple times, and it doesn't matter. As if nothing changes, we don't care, right? Because your state is already exactly what it's been defined. Whereas when you're looking at your imperative paradigms like Pulumi and Vagrant, you have to make sure that if something is already there, if we don't do a check to ignore it, there is a risk of running into errors when you try to provision something that already exists, or over provisioning and redundant provisioning, so to speak. Right, so you need to build into your scripts also the logic to remove something or to ignore something that already exists, and that's true also for our configuration management tools in Ansible, Chef, Puppet, and SaltStack. Okay, so you see over here, apart from Ansible, all of the others are more declarative in nature. So making sure that the configuration matches what you've defined. So you look at Ansible, it's very good for configuration management and application deployment. The runbooks are actually quite powerful in the sense that you can actually do a lot of things in there. You do need, however, an existing system to deploy to. Ideally, you can actually deploy it using Ansible, but it's not its strong suit. With Chef and Puppet, Chef is a good way to look at, a good tool to look at if you have more complex configurations and if you have compliance checks, because the compliance is a pretty central element to Chef. The downside to this is it does have an agent server architecture, which means you do need agents on your machines that do take a little bit of a performance overhead hit. And when you have larger clusters, that the traffic between the agent and the server do take up a little bit of the bandwidth. So those are things to look out for as well. Puppet, pretty good at security and compliance features. It does have quite a lot of that within Puppet. Configuration management is good. The installation is a bit more complex. There's a few more components that you have to install within Puppet. And Salt is good if you want it to be scalable to a certain extent. So the communication between components is actually pretty efficient. And it's good with automation of the configuration maintenance of systems. Now, the downside, of course, it's a relatively smaller community, so getting information is a bit more nuanced. So those are things to look out for. That's kind of the comparisons between them. Now, one of the things I did say I wanted to caveat that with as well is this is mainly for kind of provisioning and deploying an infrastructure and the configuration on top of that. Now, within the Kubernetes community, there is, of course, things that are kind of complement to this as well, right? So, with the rise, of our cluster API SIG group and the different organizations, including our own, that are using cluster API in their own products to deploy clusters and also for things like hosted control planes, you may want to look at some of those as well, depending on the focus of your workloads. Are you more of a traditional virtual machine shop where there's a lot of VMs, there's some containerization? Do I want to look at these tools still to manage my environment? Is it a hybrid? Is it a purely containerized? Is it a purely Kubernetes environment? So when you're more in the Kubernetes side of things, then perhaps some of these can be complemented and or even replaced by cluster API use, or for tools like our Cosmotron that actually does deploy compute and on top of that configure the Kubernetes cluster to actually give you your Kubernetes clusters on demand. So those are things that are available to you. And this is more of a general purpose as well. So this will cover everything up until this point. So that is what I wanted to talk about today in terms of the different tools and uses. I'm going to do a quick PSA on our upcoming webinars from Mirantis. So we have 2 webinars coming up. One is a Bright Talk webinar discussing the Kubernetes security through the DISA STIG process. That's a security implementation and security technical implementation guide, by from DISA. So this will be presented by head of service at Perforce, Kathleen Moyer, our own Willem Konitzer, solution architect and a good a teammate of mine, and also John Janchik, which is our director of open source initiatives at Mirantis. So this will go through the implementation of security controls required for compliance, some practical strategies for addressing your obstacles when you're looking at certification, and also the documentation and automation, maintaining compliance. So the importance of those. So these are things that are certainly going to be important for you if you're looking at hardening your environment. We also have another talk coming up on the 27th. This is a tech talk in Mirantis Lab, and looking at managing your Kubernetes environments with Lens. And this will really cover things like how do you manage your Kubernetes environments by adding multiple clusters within a single environment so you don't have that overhead of context switching. Gives you a clear understanding of your cluster health, resource utilization, all in one single visualization area. How to deploy and troubleshoot your applications without learning every single thing related to kubectl, and then how you could streamline the debugging process. So I would highly recommend you visiting both those webinars, depending on what your role is and your focus is on. If you're managing Kubernetes in any way, shape, or form, both of these will be very valuable to your day-to-day life. With that, let's go ahead and end the talk. It's been a pleasure to be able to present all of these findings to you. Look forward to seeing you in one of the following webinars and the future webinar. And hope everybody have a good rest of your day. But before I do that, yes, thank you very much.